Introducing the Thermo-Calc 2020A release. With 8 new and updated databases, the introduction of Back Diffusion to the Scheil calculator, a new general model for yield strength, and much more. The Thermo-Calc 2020A release introduces 2 new steel and iron alloy databases, TCFE10 and MobFE5. TCFE10 adds ruthenium, bringing it to a 29-element framework. The database also adds 63 new and 27 updated binary and ternary systems, as well as 34 new phases. TCFE10 also introduces viscosity of metallic liquid. This is the first time the property viscosity has been included in a Thermo-Calc software database. In graphical mode, the viscosity is plotted via the one-axis or grid calculators and then selected in the plot configuration window as either dynamic viscosity or kinematic viscosity. In console mode, the viscosity can be plotted via a step calculation versus temperature or composition. Viscosity can also be plotted in TC Python. Several other important updates are included in TCFE10, which you can read about in the release notes. The companion mobility database MobFE5 is updated to correspond to TCFE10. 2 new high-entropy alloy databases are released with Thermo-Calc 2020A, TCHEA4 and MobHEA2. TCHEA4 adds 49 ternary and 13 binary systems, as well as several improved and updated systems. The database also includes the viscosity of metallic liquid. Viscosity can be plotted, as I explained while discussing TCFE10. The companion mobility database MobHEA2 is updated to correspond to TCHEA4. The General Alloy Solutions database, SSOL7, adds 7 ternary and 108 binary systems, as well as several other improvements. 2 nickel databases and 1 copper database have been updated for the Thermo-Calc 2020A release. Read about all of the new and updated databases in the Thermo-Calc 2020A release notes. The Scheil calculator now gives users the option to calculate back diffusion in the primary phase using diffusion data from a mobility database and takes into account the cooling rate and the secondary dendrite arm spacing. This new feature uses diffusion data, so it requires a mobility database. It is available in the graphical mode, console mode, and TC Python. A new example calculation showing this feature is available for each of these 3 modes. A new example video has been created to demonstrate this new feature. You can watch the video by clicking the link in the upper right-hand corner of the screen. Several valuable features have been added to the Process Metallurgy module. It is now possible to make adiabatic calculations, which assumes no heat and mass exchange with the environment during the equilibrium reaction. When you set up an adiabatic calculation, you do not set a global temperature as condition, but rather define the temperature for each material that is added. The global temperature is then the result of the equilibrium calculation. A new example, PMET03, argon-oxygen decarburization, is available, which shows an adiabatic calculation for an AOD converter as a function of added gas amount and gas composition. Variable pressure is also added to the module, allowing you to vary the pressure as well as set it as an axis variable to step-in pressure. Component composition has also been added for solid phases, so you can now see the mass percent of solid oxides in both tables and plots. Liquid oxides were already available in the last release. The Process Metallurgy module is available for free to all Thermo-Calc users who have the thermodynamic database TCOX9 or TCOX8 and who currently have a valid maintenance and support subscription. Read about all of the new features in the Process Metallurgy module in the release notes available on our website. A new general model is added to the property model calculator, the yield strength model. This model considers 4 contributions to the overall yield stress of the material: intrinsic strength for the pure elements, solid solution strengthening, grain boundary strength, and precipitation strengthening. A user-set temperature is used for evaluating the equilibrium of the system, and the resulting compositions and phase fractions are subsequently used in the evaluation of mechanical properties. 3 new examples are included with Thermo-Calc 2020A, which show various applications of the new yield strength model. These can be found in the Help menu, Examples files, Property Models, General. A new calculation type has been added to TC Python called Batch Equilibrium. This calculation type is similar to single equilibrium calculations, but it offers significant performance improvements when calculating a lot of fast single equilibria, which are systems with few or non-complicated phases. A new example, T14 Batch Equilibria, is included to demonstrate this new calculation type. TC Python has also received performance improvements related to caching logic and managing state files. Several other bug fixes and improvements have been implemented based on user feedback. The Thermo-Calc 2020A release includes many additional improvements and bug fixes. Read about all of these in the release notes available on our website.